Hi, in this video we are going to look at the chloroquine and hydroxychloroquine. We will look at the chemical structure, the properties, the mechanism of action, the indication, contraindication, and side effects. So here we start with the chemical structure. Now the chloroquine, here we draw the chloroquine chemical formula or the structure. It has two rings within it. Now the hydroxychloroquine is not too much different than the chloroquine. If you add the hydroxyl group to the chloroquine, it becomes the hydroxychloroquine. So here we add the hydroxyl group. These drugs are used for malaria and protozoal infection, but recently it's also been used for the viral infection. So they are anti-malarial and anti-protozoal drugs, as well as antiviral drug. In case of the malarial and protozoal, they've been used for the Plasmodium species, okay? And in case of the viral or the virus, it's been used for the SARS-CoV-2, which is the COVID-19 infection. Now we look at the properties of these drugs. They are alkaline in nature, means they are bases, and they make an acidic environment alkaline when used. And they inhibit the lysosomal function. And they also inhibit the endocytosis, and they also inhibit the endosomes fusion with the lysosome. So now we look at the administration of this drug. We take the drug in the form of pills, means orally we take the drugs. Why don't we take the drug in the form of IV? Because it's a very toxic drug, right? And if you take in the form of IV, the toxicity of this drug increases and causes you a lot of damage. So if you take the drug orally, and it will be absorbed from your gut into the bloodstream, and then from the blood it will be taken to the liver. Liver is where most of the drugs are detoxified, and here it will be metabolized into desethylchloroquine, the main metabolite of this drug. This metabolite will be absorbed well into your tissues, and then it will remain in the tissues or in your body for 2 to 5 days or up to weeks. And then it will be taken to the kidney and excreted 70 to 75% through urine. Now, this is how it's being administered and removed. Now, let's look at the mechanism of action of the chloroquine and hydroxychloroquine. Here we draw the plasmodium cell. Let's imagine this is the plasmodium cell. It has the nuclear material and genetic material here, and it has the food vacuole, which is called the lysosome. So here is the lysosome. Now the lysosomes, they contain the enzymes. Now these enzymes are digestive enzymes, and here we show the enzymes, and the function of the enzymes is to degrade the abnormal protein and other cellular particles. Now, if we look at the function of the lysosomes, as we know, it has the digestive enzymes. Now, these digestive enzymes work in a pH. When the pH is low and the environment is acidic, they will degrade, they will digest, and they will remove the waste product, the excessive or worn out cells, bacteria, and viruses. So lysosomes, they function as if it's the immune system of a cell, because it removes the bacteria, viruses, and abnormal protein. And it has a low pH, means it has the acidic environment within the lysosome, which is very good for the enzymes to work. Now, it has a ATPase here, and this ATPase function is it uses ATP and pumps in the proton ion and makes the environment more acidic, right? And brings down the pH of the lysosome. Now, what happens if you take chloroquine and hydroxychloroquine? These drugs will interfere with the acidity or the acidic environment within the lysosome. It will make it more basic, more alkaline. And the alkaline environment will increase the pH, and that will inhibit the enzymes. And it will also inhibit the ATPases, and there will be no hydrogen ion influx, decreasing the proton influx, increasing the pH will inactivate the enzymes, and inactivated enzymes will not be able to digest. It will starve to death. So that's how the plasmodium cells are being killed by these drugs. Now we look at the antiviral function of the chloroquine and hydroxychloroquine. Here's the lipid bilayer of a human cell, let's imagine. And here is the bilayer of the viral cell, and here it has the RNA within it. Let's say this is the COVID-19 or SARS-CoV-2. It has the different proteins on its surface, but this one in blue is the S protein or the spike protein. This spike protein has a receptor on the human cell membrane called the ACE receptor or ACE2 receptor, right? And once this spike protein comes in contact with the ACE receptor, the virus will be taken inside the cell through a process called the endocytosis. So here, the binding of the spike protein with the ACE receptor, and then through the endocytosis, it will be taken in and it's covered by another membrane called the endosome. Within the endosome, there is the virus. So the process is called the endocytosis. Now, there is another glycoprotein, means another receptor, which is called the sialic acid. This receptor is believed to help the bacteria and viruses to bind to the human cell, right? This is the function of this receptor. So we will come back to this, okay? So here we start again with the endocytosis. Once the virus is being put into the endosome, it will fuse with this lysosome. And you know the lysosome have the different enzymes and it will degrade the virus, okay? So here the fusion, right? Now, I don't understand why do we give the hydroxychloroquine, because it will inhibit the lysosomal function and it will not allow the cell to degrade this virus. So this virus will inhibit the fusion of endosome and lysosome. And it also inhibits the ATPases, means making the cell more alkaline, right? Drop in the proton ion and increase the pH and inhibit the lysosomal enzymes. Okay, so this is the mechanism, one mechanism how the hydroxychloroquine and chloroquine works, right? And this drug or these drugs, they also bind to this receptor. And when it binds to this receptor, it does not allow the virus or the bacteria to bind to this receptor and enter the cell, which is something very good. And this is the new study, and this is the new mechanism found in April 2020, which is a very good mechanism and does not allow the endocytosis. It inhibits the endocytosis. Now, the chloroquine is also believed to be a zinc ionophore. This study was published in 2014, right? Now, if you take in the zinc, the zinc will not penetrate the membrane. So you need the chloroquine to get into the to get the zinc inside the cell. So here the zinc will not enter because it's not permeable membrane. So the chloroquine kind of works like a ionophore. It becomes like an ion channel, and that allows the zinc to get inside the cytosol. Now, when a virus enters the cytosol and infects the cell, it releases its RNA, and this RNA is being translated by RNA-dependent RNA polymerases, RDRP. Now, the viral RNA, once translated, will be making more copies through the RDRP, and these new copies will leave the cell and become the new virus, right? But the increased level of zinc in the cytosol is believed to inhibit this process and inhibit the translation of the new viral RNA copies. Now, this is all about the mechanism of action. Now, let's look at the indication of the chloroquine. It's been used in the rheumatological conditions like SLE or lupus. It's used in dermatomyositis and rheumatoid arthritis. It's contraindicated in people who had previous hypersensitivity reaction to chloroquine and hydroxychloroquine, and it has some adverse effects like side effects. The common side effects of the chloroquine and hydroxychloroquines are headaches, dizziness, abdominal pain, vomiting, diarrhea, which is the GI upset, the pruritus. The less common adverse effects if we start with the CNS, it's agitation, anxiety, confusion, delirium, depression, hallucination, and psychosis. On eyes, it will cause macular degeneration, retinopathy, and corneal opacity. On ears, it will cause hearing loss and tinnitus, which is the ringing of bells in your ear. And then on the GIT, it will cause the abdominal cramps, decreased appetite, nausea, vomiting, and diarrhea. Now, in case of the CVS, it will cause the prolonged QT interval, the AV block, the bundle branch, and effects on the liver will cause hepatitis. And effects on the muscles will be proximal myopathy. On skin, it will cause the pruritic macular papular rash, hyperpigmentation, hair loss, and Stevens-Johnson syndrome. And its effects on the blood will be like anemia and pancytopenia and aplastic and hemolytic anemia. And in case of the glands, it will cause the hypoglycemia. So this is all about the adverse effects of the chloroquine and hydroxychloroquine.